we are going to cover the pre-assessment for linear equations and graphing them. So when we deal with linear equations, I showed you three different forms. You have, not that one. You have, nope, still not that one. You have slope intercept form, which is y equals mx plus b. You have standard form, and standard form look like this: ax plus by equals c, and then you have point slope form. And point slope form was y minus y sub 1 equals m times the quantity x minus x sub 1. So if we look at this, there's pieces of information that we can pull out. When it's in slope-intercept form, the coefficient of x is equal to the slope, and b is going to be the y-intercept. So that's nice and convenient. M equals the slope, and b equals the y-intercept, hence the name slope-intercept form. When we see point slope form, we can notice the similarities. There's some similarities, that that m is the slope, and in this case, x and y are points. That's a point. This x and y are points. This x and y are points. And here's the trick question on this one. X sub 1 and y sub 1 are also a point. In standard form, there's no other information other than x and y. We can do a point is x comma y. In this one, x comma y is a point. And we're going to use this equation to find, it's not straightforward, but we're going to find the x and the y intercepts when we are in standard form. So that's going to help us graph the line. In slope-intercept form, we're going to plot the y-intercept, and then we're going to utilize the slope. We're going to plot the two x-intercepts, or the two x and y-intercepts, and then we're going to graph it because you only need 2 points. In point slope, m equals the slope, and then x sub 1, y sub 1 is the point that will be given. So you're going to plot the point and then utilize the slope. So that's the sort of brief review of those three forms that I gave you. So the first question says, find the slope of each line. So when they give you the 2 points, you're going to use slope equals the rise over the run. And when we rise, we either go up, down, or when we run, we go right or left. Up is going to be positive, down is going to be negative, right's going to be positive, left's going to be negative. So from one point to the other, from this point to this point, how do you go up and down and then right and left? Well, if we have to go up and down from this point to get to this point, we're going to go up 2. So my slope is up 2, and then we're going to go to the right 1. Let's say we chose to do this point first, and then to get to this point, this blue point. Again, knowing that we have to do the up, down first. So we would go down 2, and then we would go left 1. So up 2, let's look at this, what I call slopees. Up 2 is positive 2, right 1 is positive 1, so my slope of this line is going to be 2. If we look at the down 2, left 1, down 2 is negative 2, left 1 is negative 1, and that simplifies to 2 also. So the slope of this line right here, would be 2. So that would be your answer. Now we can do it a little bit faster. I'm going to start with this point, move to this point. I go up 2, and I'm going to go right 1, 2, 3. Up 2 is positive 2, right 3 is positive 3. So my slope is 2/3. I'm going to go from this point to this point again. I go up 1, and then I go right 1. That's 1/1. I cannot leave it as 1/1. I must simplify all fractions. So my slope is going to be 1. Ooh, look at this one. So I'm going to use this point to start, and I'll move to that point. So how much do I go up and down? I go up 0, right 1, 2, 3, 4, 5. Right 5, 0/5 equals 0. Slope can equal 0. That can be a value. 0 is a value. Now, here we were given 2 points, but we did the manual up-down because it was on a graph. We are not going to put these values on a graph. Do not graph them. That's not what we're practicing. Do not graph. We want to use the equation. I want to see you use the equation. So we know slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, point 1 is going to be x sub 1, y sub 1. That's the x value for the first point. This is the y value for the first point. Point 2 is going to have values x sub 2, y sub 2. This is the x value for the second point. This is the y value for the second point. We have 2 points here, point 1 and point 2. And this is going to be the x value for the first point. This is going to be the y value for the first point. This is going to be the x value for the second point, the y value for the second point. And we're going to substitute those in for these. So we have y sub 2, my y value for my second point, which is 11, minus, not grand, minus my y sub 1. What's my y sub 1? My y sub 1 is going to be the y value in the first point, which is -9. That's negative. This is a different negative than the -9 negative. This negative is this green one from the starting equation. These correspond to each other. This negative here is from the negative in the value. That's the -9. All right, so that's very important. Lots of students will make their mistakes there. My x sub 2 value, is going to be 11 minus my x sub 1. This is my x sub 1, which is 11. You have 11 minus -9, which is 11 plus 9, which equals 20. And you have 11 minus 11, which is 0, 20/0. So when we have a slope of 20/0, we can't have 0 in the denominator. You can't eat 20 slices when you don't even have a pizza to eat. So this is going to be no slope. No slope. We can't have 0 in the denominator. When we have this is my x sub 1, y sub 1. This is my x sub 2, y sub 2. The equation again is y sub 2 minus y sub 1, x sub 2 minus x sub 1. Y sub 2 is 20 minus y sub 1, which is 2, over x sub 2, -20, minus x sub 1. So we have 20 minus 2, which is not -18, 18. And we have -20 plus 2, which is -18. 18 over -18 is -1. My slope is going to be -1. You cannot leave it. Must simplify this value. I always like writing this. You will see that I will always label my 2 points with those two notations because it just makes it easier. When you look with your eyeballs after you write this part, y sub 2, oh, that's 10. I look up at it, minus y sub 1, that's 18, over x sub 2, 5, minus my x sub 1, which is negative 13. 10 minus 18 is negative 8. 5 plus 13 is positive 18. Negative 8 over 18 can be simplified to negative 4 over 9. And no number goes into 4 and 9. So my answer is negative 4/9 as my slope. Last one, x sub 1, y sub 1, x sub 2, y sub 2. Takes 2 seconds to do that. Y sub 2 minus y sub 1, x sub 2 minus x sub 1. Always remember y's over x's. And it's rise. Rise goes up and down on the y-axis. Over run. Run is along the x-axis. That goes right and left. So y sub 2 is negative 7 minus y sub 1, which is negative 7, over negative 5 minus negative 7. Negative 7 plus negative, so sorry, it's negative 7 minus negative 7 makes plus 7. These two negatives make negative 5 plus 7. That's 0 over 2, which gives me a slope of 0. 0 can be in the numerator. You can eat 0 slices of a pizza that is broken into 2 parts, and that simplifies to 0. Now, find the slope and the y-intercept of each line. Okay, what form is this? Well, this is in slope-intercept form. How do I know? I know that because y is isolated. That's not how you spell isolated. When y is isolated, it's in this form, y equals mx plus b. Well, this is a unique one because, wow, I only have a 1. Remember, b is your constant. So we don't have an x value. How can we not have an x value? Well, the only way you can have no x value is if m is 0. So we can think of this equation as y equals 0x plus 1. That's a nice way of rewriting this starting equation. So now it makes it a little bit easier. My slope equals 0 and my y-intercept equals 1. I don't have to graph it. It doesn't say graph. It just says find the slope and the y-intercept. So you need to let me know what each of those are for each of these equations. So number 10, this is in more of a traditional y equals mx plus b. So my slope is going to be the coefficient of x. It's the number in front of x, which is 5/3. And my y-intercept is going to equal negative 1. It's the constant. It's the number without the variable. Again, this is in standard slope-intercept form. I know that because y is isolated. Y is by itself. So my slope equals negative 2, and my y-intercept is equal to 1. Now, pulling this information allows me to graph. It's not asking you to graph, but that's why we like this, is we can find the slope and the y-intercept, and that allows us to graph it, which will come later. Here we again have y isolated. Y is by itself, so the number in front of x is the slope. So my slope of the equation of this line is 6, and my y-intercept is whatever is being added and subtracted. Well, what do we notice? There's nothing being added or subtracted to my x, so my y-intercept is actually 0. All right, this is the first sketching, so now we have to graph. When we graph, remember, we need to draw a line with 2 arrows, and we have to plot 2 points and label them. So we know this is in slope-intercept form because y is by itself. So I'm able to pull out the slope and the y-intercept. The slope of this line is 5/3. The y-intercept is going to be 3. I'm always going to graph my point. I can't use up 5, right 3. That's slope ease. That's slope ease. I can't go up 5, right 3 until I have a point. Well, the point that I'm going to utilize is the y-intercept, where the line crosses the y-axis. So we know it's going to cross at 3. 1, 2, 3. I'm going to make a dot. And now I'm going to use my slope. Up 5. 1, 2, 3, 4, 5. Right 3. 1, 2, 3. So there's my second point. I'm going to make a line. I'm going to draw arrows. And then I'm going to label my points. 0 for x, 3 for y. And this point is going to be 3, 8. 3 on the x, 8 on the y. Now I know that because I went 5 up 5 from 3. 4, 5, 6, 7, 8 for the on the y-axis. And then I went right 1, 2, 3, which took me to 3 on my x value. Some of you could have seen, hey, 5/3, I came up and off of it. You know that -5 over -3, these two are equivalent. So this would mean down 5, left 3. Down 5, 1, 2, 3, 4, 5, left 1, 2, 3 takes you to this point. And that coordinate is a little bit easier to see, -3, -2. So either of those points, this point you absolutely, everybody should have. This is a point that everyone will have. And then depending on those two, whether you went up 5, right 3 off the graph, which is okay, or whether you stayed on the graph by going down 5, left 3. Either one is okay, but we need 2, not all 3, but everybody must have this one and one of the other 2. Here, we should notice something that we should be aware of. Hey, look at that. That's a red flag. We should observe there is only one variable. When there's only one variable, it's either going to be vertical or horizontal. So this is going to be x equals because it's going through the x-axis. This is going to be y equals because it's going through the y-axis. This line would go across the y-axis. Now, we can look at this and we can also see that it's in slope-intercept form. How do I know that? Because y is isolated. It doesn't have an x value, so that tells me that the coefficient of x must be 0. That's why I don't see an x value. And if it's in this shape, I should know immediately that my slope equals 0 and my y-intercept equals -4. My y-intercept is -4. I'm going to make a dot at -4, and then I'm going to use my slope. 0 as a fraction is 0 over 1. That means I go up 0, right 1. So up 0, right 1 takes me here, and I have 2 points. I can connect the dots. I write the coordinates 0, -4, 1, -4. And notice also the way that I talked about, I also taught you, if you didn't understand that, is when y equals -4, we know it's going to cross the y-axis at -4. That all of your points, your y is going to be -4. What's your y value here? -4. What's your y value here? -4. If we chose that point, that was 6, -4. What's your y value? -4. No matter what your x value is, no matter what you plug in for x, no matter what you substitute in for x, y is always going to be -4. Slope-intercept form, y equals mx plus b. My slope equals -3. My y-intercept, again, is -4. So let's plot that y-intercept, and now we use the slope. -3 as a fraction is -3 over 1. That means down 3. +1 is right 1. Down 3. 1, 2, 3. Right 1 takes me here. And I can connect the dots. That's a horrible line, but It's not going to be perfect. This is 0, -4. This point is going to be 1. How many did I go down? I went 1, 2, 3. So that is going to be -7. 1, -7. The other way, excuse me, -3. -3 over 1 is equivalent to 3 over -1. That's the same fraction, so we could have gone up 3, left 1. Up 3, 1, 2, 3, left 1 takes us here, and that coordinate would be -1, -1. So everybody's going to have the y-intercept. Everybody's going to have this point. And then some of you are going to have this point or this point. 16, in slope-intercept form, the slope is going to be the coefficient of x. The y-intercept is going to be the constant. So I know that my y-intercept is -1. My slope is 3. That's up 3, 1, 2, 3, right 1. Or down 1, 2, 3, left 1. So either of those points, everybody's going to have 0, -1. Some of you are going to have 1, 2, and some of you are going to have -1, -4. That's how fast and easy it can be to graph these. Notice this one is not isolated for y. We have x and y on one side and my constant on the other. When we see it in that manner, x, y, we know that it's in standard form. And when we're in standard form, what we do is we find the x and y intercepts. We remember that the x-intercept, my y value is always going to be 0. And when we find the y-intercept, I know that every y-intercept, my x value is 0. So we like that. We utilize that when it's in standard form. So we create two equations. We're going to rewrite the starting equation. And if we're finding the x-intercept, we plug 0 in for y. So 4x minus 0 equals 4. 4x minus 0 is 4x. Divide by 4, divide by 4, x equals 1. So this is my x-intercept. If I'm looking for the y-intercept, I know that x is always going to equal 0. Using my starting equation, I'm going to plug in 0 for x. So we get 4 times 0 minus y equals 4. 0 minus y equals 4. 0 minus y is -y. We have not solved for the variable. There's still a -1 there. So we can divide by -1. We get y equals -4. This is going to be my y-intercept. So x-intercept, where it crosses the x-axis at 1. Here's my x-axis at 1. Y-intercept is -4. So on the y-axis, I find -4. That's down here. I have 2 points. I connect the dot. I write the coordinates. This is 1, 0. This is 0, -4. Make sure that you write the coordinate as x, y. Also in standard form, this is a trick one. We should notice only one variable. When there's only one variable, it's either vertical or horizontal. This is going to go through the x-axis at 3. This is how easy we can do it. Goes through the x-axis at 3. The only way that you can go through the x-axis and have 3 as your coordinate each time is this way. And that is 3, 0. Those are your 2 points. That's how fast you can do it. Now, if you want to look at it as standard form, if you have x equals 3, what does that look like in ax plus by equals c? It would look like, 0x, 1x plus 0y equals 3. That's converting this into standard form. That's what it looks like. So we can split them still. And x-intercept, we know that y equals 0. Y-intercept, we know that x equals 0. So let's rewrite the equation. Let's plug in 0 for y. You have 1x equals plus 0 times 0 equals 3. You have 1x plus 0 equals 3. You have 1x equals 3, which means x equals 3. That's your x-intercept. That's where the line crosses the x-axis. X-axis, that coincides with what we wrote earlier. Now let's do the y-intercept. So here's our starting equation. Plug in 0 for x. 1 times 0 plus 0y equals 3. 1 times 0 is 0. 0 plus 0y is 0y. And now we divide by 0. And we get y equals, oh, that's impossible, so no y-intercept. Does this line cross the y-axis? No. So that means it has to be a vertical. Good? Good. Standard form, 3x minus y equals 0. So let's set each of them up. X-intercept, y equals 0. 3x minus 0 equals 0. 3x equals 0. Divide by 3, divide by 3. 0 over 3 you can have. That gives you 0. If you do the y-intercept, you're going to plug x in for 0. We have 3 times 0 minus y equals 0. That's 0 minus y is 0. Negative y equals 0. We're going to divide by negative 1. 0 divided by negative 1 is 0. So what we notice here is that the x-intercept is 0, and my y-intercept is also 0. So we only have 1 point. So we can't graph it. We need 2 points, and we can't really find another point by using this technique. So at this point, we have to find another point. How do we find another point? The easiest way to find additional points is by using an H-chart. What was the original equation? 3x minus y equals 0. 3x minus y equals 0. And an H-chart looks like this. So we have to pick a value. What value do we want to plug in for x? Well, 0 would be good, but we've already done 0. That's how we got our intercept. Remember, we plugged in 0 for x already. And when we plug in 0 for x, we get 0 for y. That's why that coordinate is 0, 0. That coordinate is 0, 0. We've already tested 0 for x. So what's another easy value to plug in for x that we might want to plug in? 1, yes. So we're going to pick the value 1. We're going to put it in for x. And we're going to isolate for y. Because notice, we only have one variable. So 3 minus y equals 0. Well, I didn't mean to double. So you subtract 3. You get negative y equals negative 3. Let's divide by negative 1. And y equals 3. So when x equals 1, my y value will always be 3. So that coordinate, that xy coordinate, plugged in 1 for x, and it produced 3 for y. So we go over here on our graph, 1 for x, 3 for y. We have our second point. Once we have 2 points, we can graph it, and let's write the coordinate of that other point. So we have 2 points, 2 coordinates, and a line with 2 arrows. Still in standard form, x minus 3y equals 3. Let's solve for the x-intercept. We plug 0 in for y. So x minus 3 times 0 equals 3. X minus 0 equals 3. X equals 3. That's my x-intercept. On the x-axis, I make a dot. When we want to find the y-intercept, we plug 0 in for x, 0 in for x, solve for y. negative 3y equals 3, divide by negative 3, y equals negative 1. It's going to be my y-intercept. Y-axis, negative 1. I have 2 points, arrow with two, or a line with 2 arrows. That's 0, comma, negative 1. This is 3, comma, 0. All right, now, whoa. Most people would say that's not in any format, but if I rewrote that, if I just flipped it, I should be able to see and recognize that that's slope-intercept form. So I'm going to pull out the slope, which is the coefficient of x, and I'm going to use the y-intercept, which is 1. So I plot my y-intercept, crosses the y-axis at 1. My slope is 1, up 1, right 1. Connect the dots, and I am done with this chart. 0, 1, and that is 1, comma 2. 1 on the x, 2 on the y. That's how I knew that coordinate. And I'm done. This one, again, we can do some rewriting. If I write negative 5x, I see that that negative is attached to the 5, plus 2y equals 4. So I didn't move anything mathematically. I just rewrote it a little bit. This is on this side of the equal sign, so I could have written negative 5x plus 2y equals 4, and then I just flipped it. I wrote that before that. So this is in standard form, so I know I'm going to find the x-intercept by plugging 0 in for y. So negative 5x plus 2 times 0 equals 4. Negative 5x plus 0 equals 4. Negative 5x equals 4. Divide by negative 5, divide by negative 5, and we get x equals 4 over negative 5. This is not the slope. This is my y, or my x-intercepts. So it's going to cross the x-axis at negative 4/5. X-axis, negative 4/5 is less than, a little bit less than negative 1. Now my y-intercept, x equals 0, so negative 5 times 0 plus 2y equals 4. 0 plus 2y equals 4. 2y equals 4, divide by 2, and I get y equals 2. That's my y-intercept. So I have 2 points, and yes, that's a fraction right there. This is 0, 2, and this point is going to be negative 4/5, comma 0. Everybody should have those 2 points as as the 2 points that you use. You could solve for y, I guess. You could have solved for y because let's talk about that. So you have 4 equals 2y minus 5x. So some of you maybe wanted to put it in slope-intercept form. So you could do plus 5x, and you get 5x plus 4 equals 2y. Divide everything by 2, and you get 5/2 x plus 2 equals y. If we wrote the y first, that's y equals 5/2 x plus 2. So my slope is going to be 5/2, and my y-intercept is 2. So my y-intercept is 2. Let's go up here. Y-intercept is 2. Point's already there. And then my slope is 5/2. So I could have gone up 5. 1, 2, 3, 4, 5. No, let's not do that way. 5. And then right 2. 1, 2. So it's kind of close to it. So my other point is going to be this, and that would be 2, comma 7 would be your other point if you use the slope-intercept. So these would be your 2 points if you changed it to slope-intercept form. If you used standard form, these are your 2 points that you should be using. Okay? A little clarification there. Whoa, look at that thing. Holy moly. All right. Well, it's kind of close to slope-intercept form where we isolate for y, because all we have to do is get rid of that negative 1/5 that is multiplying by the y. So how do I get rid of that? I don't want to divide by negative 1/5. I want to multiply by the reciprocal. So I'm going to multiply everything by the reciprocal of negative 1/5, which is negative 5. And I'm going to multiply everything. Just like I divide everything, I have to multiply everything. Negative 5 times 1 is negative 5. Negative 5 times 1/2 x gives me negative 5 halves x equals y. Let's just rewrite it in slope-intercept form in the y coming first. So I'm able to figure out what my slope is, which is negative 5 halves, and I'm able to find what my y-intercept is. So my y-intercept is negative 5, and I'm going to use my slope. Oof, down 5. 1, 2, 3, 4, 5, right 2. Takes me right about here. If I flip it and do the other way, meaning if I wrote it as 5 over negative 2, that's going to be up 5. 1, 2, 3, 4, 5, left 2. So I could have those. Either of those points works. How cool was that? That was pretty fun. So negative 2, 0 is one of them. Zero, negative 5 is another point. And this is going to be 2, comma, negative, what's that? 5, 6, 7, 8, 9, 10? Negative 10, yes. So any of those points, any of those, 2 of those 3 would probably be the most likely, especially if you put it in slope-intercept form. Standard form, anybody change it to standard form? You have 1 plus 1/2 x, I think is what it was, equals negative 1/5 y, equals negative 1/5 y. So if you want to put it in standard form, this is what you do first. First of all, I got to get rid of these denominators. What's the common denominator of 2 and 5? What number can I multiply to get rid of both of those denominators? If I just multiply everything by 5, it doesn't get rid of that denominator. Definitely cancels with that denominator. 5 in the numerator, 5 in the denominator, cancels. But it wouldn't get rid of that denominator. So we have to pick a multiple of these two numbers, which would be 10. So if I multiply everything by 10, we get 10 plus 5x, 10 times 1/2 is 5, equals negative 2y. Denominator, numerator, negative 1 times 2, etc. So now we're kind of close to standard form. Standard form, we want our x and y on one side and our constant on the other. So if I add 2y, I get 10 plus 5x plus 2y equals 0. And then let's subtract that 10. Trying to extend that page. I don't want algebra 2. There we go. That's going to give me 5x plus 2y equals negative 10. So if I wanted to find the x-intercept, I'm going to plug 0 in for y. 5x plus 2 times 0 equals negative 10. We're left with 5x equals negative 10. Divide by 5, divide by 5. My x-intercept is negative 2. Is that the case? Let's go back to my original graph. My x-intercept is negative 2. Yes, that worked. We love it. Now if I wanted to find my y-intercept, I'm going to plug 0 in for x. So 5 times 0 plus 2y equals negative 10. That leaves me with 2y equals negative 10. Divide by 2, divide by 2. Y equals negative 5. Was my y-intercept negative 5? Let's check it out. My y-intercept was negative 5. So if you did standard form, you're going to get those two values. Good? That's a good one. Woo! All right, here we go again. You have to decide what form do you want, what format. Do you want it in slope-intercept form? Or do you want it in standard form? You choose what you think is the easiest way to manipulate this equation to get it into this format. Y equals mx plus b, meaning you've isolated for y. Do you want to get y by itself? Or do you want to be in standard form where you have ax plus by equals c? Do you want your x and y on one side and your constant on the other? So that's up to you. What are you most comfortable with? If you're putting in slope-intercept form, that's not right. We're going to divide by 5, divide by 5, divide by 5. You get 3 plus 1/5 x equals y. So that equation looks like y equals 1/5 x plus 3. That's nice and easy. We have our slope. We have our y-intercept. So that point, those points, y-intercept of 3, slope of up 1, right 5, 1, 2, 3, 4, 5, down 1, left 5, looks like that. So that graph looks like that. These coordinates are 0, 3. This is 5, 4, and this is -5, 2. If you did it in standard form, if you have 15 plus x equals 5y, we're going to subtract 5y to get my x and y on the same side. And then we're going to get the constant. Whoops, that should be 0. Then we get our constant over on the other side. And you get x minus 5y equals -15. So what does that look like? If we want the x-intercept, you plug 0 in for y. So x minus 5 times 0 equals -15. X equals -15. That's my x-intercept. Let's look and see where this, oh yeah, see? We would have been way, way down over here. So we can't really see because my graph ended at -6. But at least it's in the right general vicinity. So your point there would be -15, 0. And then y-intercept, you're going to plug 0 in for x. You have 0 minus 5y equals -15. -5y equals -15. Divide by -5. -5y equals +3. Negative divided by a negative is positive. Is my y-intercept 3? Yes, it is. So that's cool. That worked. Now, the last 3 problems are in point slope form. Remember, point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. Slope is still there. Super easy. Slope is 3. Now, what we have to remember is what we see is the opposite of what we want. What we see is the opposite of my y value. We see the opposite of what we want. When we want a point, the point is going to be x comma y. But we see the opposite of y sub 1. We see the opposite of x sub 1. We want x sub 1, y sub 1 as our point. That is the point that is given to us. So when we see this, we see the opposite of what it really is. So we see -1, we see -3. Now the most important part is, remember, coordinates are written x comma y. So I'm going to look at my x, the value, the constant next to my x, which is -3. What we see is the opposite. So the opposite of -3 would be 3. And here is my y variable. So this is going to be my y value. I see a -1. I know it's the opposite of what we see. We see the opposite of what we want. So we see a -1, we see a -3, we know that those values are going to be opposite. So we're going to plot that point. That's going to be our 0.31, which is here, and then we're going to use our slope. Our slope is 3, up 3, 1, 2, 3, right 1, or down 3, 1, 2, 3, left 1. My coordinates that I can use are 2, -2. We have 3, 1, which is our point. And then we have 4, 4. Oh, very interesting. Good. So any of those 3 points. You're definitely, everybody is going to have this point because that was given in the equation. This is point slope, so we are definitely going to have that point. Everybody's going to have that common point, and then using the slope, you'll either go up or down. So we again find the slope and we find our point. The slope of this line equals 1/2, and the point is going to be the opposite of what I see. I'm going to go to my x value first. I see a +4, so I know it's going to be the opposite of that. I find my y, and I know I'm going to go the opposite of what I see. So I'm going to plot -4, -2, and I'm going to use my slope, up 1, right 2, or down 1, left 2. Those are the points, not very big, and it's okay because I'm going to write the coordinates. So I'm going to use my super easy first coordinate, -4, 2, -2. Oh goodness, -4, -2 is right there. I kind of wanted to move that, so I will erase it. What? Sorry. That looks about, nope. Oh yeah, that looks good. Got to go to the pen, -4, -2, and then I'm going to use this, which is -2, 1. Your other point would have been -6, -3. Point slope is equally as simple as slope intercept because they give you the information. My slope is going to be -2/3 or 2 over -3. There's only one negative. That negative doesn't look like it's in the numerator or the denominator, so I got to decide. Are you going to put it in the numerator or are you going to put it in the denominator? But there's only one. And then my point is going to be the opposite of what I see. I see a -6 next to the x, so the opposite is going to be 6. I see a +1 next to the y, so I know that's going to be the opposite of that. 6, -1 takes me here. My slope is down 2, right 3, gets me to that point, or up 2, left 3, which takes me here. So I'm going to connect those, and I'm going to write the coordinates. That is 3, 1. This is 6, -1. And this is, let's see that. That's going to be 9, -3. Boom! That was a long one. A lot of work there. Good. Good luck. Come and see me if you have questions before the assessment. Awesome job. Good luck.